Hello everybody, today I can prove parallelograms using coordinate geometry by knowing my how do you proofs and calculating distance. This is a very important lesson. Here's your how do you proofs. This is what you need to know. This is like your Bible for coordinate geometry proofs. It's telling you exactly what you need to do for each type of shape. And today we're going to be focusing on the parallelograms, which are these four. So, the structure is going to be the same as yesterday's lesson. Let's start by plotting the points. M is -2, -3. A is -1, -1. T is 4, 2. H is 3, 0. So, 1, I always state what they want me to prove. Math is a parallelogram because and we refer to our how do you prove, because it has two pairs of opposite sides congruent. So I'm going to have to prove that it has two pairs of opposite sides congruent. So two pairs of opposite sides congruent is four distances. I have to find the distances of all four sides and show that it has two pairs of opposite sides congruent. So I'm going to find the distance of, let's use colors here, MA, the distance of TH. That's going to be one pair of opposite sides. And then I'm going to find the distance of AT and MH. So distance, we've been doing for quite a while now, radical delta x squared plus delta y squared. MA is 1, 1, 2. That's 1 plus 4, and 1 plus 4 is 5. TH is 1, 1, 2. That's again 1 plus 4, which is rad 5. Now I'm going to do distance of AT. That's going to be AT 1, 2, 3, 4, 5. 1, 2, 3. 5 squared is 25. 3 squared is 9. 25 and 9 is 34. And H, 1, 2, 3, 4, 5. 1, 2, 3. Is rad 25 plus 9 is rad 34. So I was supposed to show that it had two pairs of opposite sides congruent. I did. The rad 5s are the same, the rad 34s are the same. So 3 ties everything together. I said in step 1 that it has two pairs of opposite sides that are congruent. What pair of opposite sides are congruent? Well, MA is congruent to TH, and AT is congruent to MH. Because, same as yesterday, whenever I prove segments are congruent, it's because they have the same distance. And that's it. Step 1, state what they want you to prove because, and then finish that sentence from this sheet right here. Have this sheet, it's in the front of your packet, take a picture of it, have it to refer to whenever you're doing your coordinate geometry proofs. Step 2 is to calculate the distances that you need for that, and step 3 ties it all together. If you say it has two pairs of opposite sides congruent, tell me the opposite sides are congruent, because they have the same distance. I'm going to skip 2. We're going to do 3. You know what we're going to do? Yeah, we're going to do 3. Let's start by plotting the points. A is 2, 0. B is 6, -4. C is 10, 0. D is 6, 4. Prove that ABCD is a square. So I start by saying ABCD is a square because. Well, flip back here. I want you to finish the sentence. ABCD is a square because. And I'm looking right here. You finish that sentence on your own. I'll give you a few seconds. ABCD is a square because all sides are congruent and diagonals are congruent. All sides are congruent and diagonals are congruent. So whenever I'm dealing with diagonals, I'm going to have to calculate 6 distances, the 4 sides and the diagonals. So I'm going to find AD, I'm going to find DC, I'm going to find CB, I'm going to find BA, and I'm also going to find the diagonals AC and DB. I want you to pause, calculate all 6 of those distances, and then unpause. Now that you've calculated all those distances, I will go over it for you. 1, 2, 3, 4. 1, 2, 3, 4. 4 squared plus 4 squared is 16 plus 16 is 32. DC 1, 2, 3, 4. 1, 2, 3, 4. 4 squared plus 4 squared. 16 plus 16. We're at 32. CB 1, 2, 3, 4. 1, 2, 3, 4. 4 squared plus 4 squared is 16 plus 16 is we're at 32. BA 1, 2, 3, 4. 1, 2, 3, 4. 4 squared plus 4 squared, 16 plus 16, we're at 32. Now, in this particular case, the diagonals are a little bit easier because they're straight lines. If it's a straight line, you don't have to use distance formula. It's just 1, 2, 3, 4, 5, 6, 7, 8. You don't have to use distance formula when it's a straight line. DB 1, 2, 3, 4, 5, 6, 7, 8. I showed that all sides are congruent, and I showed that diagonals are congruent. So now I tie it all together. All sides are congruent, so tell me what sides are congruent. AD is congruent to DC, is congruent to CB, is congruent to BA. That's how I state that all sides are congruent. And AC is congruent to DB. That's the diagonals congruent because they have the same distance. So again, one, state what they want you to prove because, and then look back at your how do you proves. The answer to that is there. In this case, all sides congruent and diagonals congruent. Then you calculate all the distances. When there's diagonals involved, for rectangle and square, there's 6 distances. And then tie it together. I said that all sides are congruent, so tell me what sides are congruent and diagonals are congruent. Tell me what diagonals are congruent. And step 3, it's always because they have the same distance. So we're going to take a look at number 4 now. F is -2, -8. R is 7, -1. D is 10, 10. Y is 1, 3. Prove that quadrilateral FRDY is a rhombus but not a square. So I'm going to start by saying that FRDY is a rhombus but not a square because. Well, how do I prove a rhombus? All sides are congruent. All sides are congruent. Now, it wants me to prove that it's not a square. If it's not a square, then it's not going to have the extra property. To prove a square, I prove that the diagonals are congruent. So to prove it's not a square, the diagonals will not be congruent. So if it says to prove something is not a shape, then you have to prove it doesn't have the property. All the sides congruent makes it a rhombus. So because all sides are congruent, and the diagonals are not going to be congruent. So if they want you to prove it's not the shape, you're going to prove it doesn't have that property. Because there's diagonals involved, we're going to have to calculate 6 distances. So I want you to pause, and I want you to finish the proof from here. I want you to do the 6 distances, and then I want you to do step 3, use this as a model, and I want you to, again, try to do the rest of this. So again, pause, complete the proof, and then unpause. It should take you a few minutes. Okay, now that you did it on your own, I will go over it with you. I'm going to calculate all the distances. I'm going to calculate FY, YD, DR, RF, and the diagonals, YR, FD. One, two, three, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 9 plus 121. You can calculate it if you need to. That's 130. YD, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. You might be saying, Mr. Schlansky, those aren't the same as 3 and 11. Well, 9 squared is 81, 7 squared is 49, 81 plus 49 is 130. The delta x and delta y don't have to be the same, it's just when you finish calculating the distance, it needs to be the same. dr, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. RF. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. Rad 130. So that's me showing that all the sides are congruent. Now I got to do the diagonals. YR is, let's just do a different color for that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And since I'm proving the diagonals are not congruent, I should not get the same distance for each of them. FD is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 12 squared plus 18 squared. 144 plus 324. 468. I wanted to show that they are not congruent. I did. Now I tie everything together. I said in step 1 that it had all sides congruent. So FY is congruent to YD, is congruent to DR, is congruent to RF, because they have the same distance. And it wanted me to say, it said in step 1 that diagonals are not congruent. So tell me that the diagonals, YR, is not congruent to FD because they don't have the same distance. And this would be a 6-point Regents question. It's really not bad once you practice it, and it's a lot of points that we can get. So I can prove parallelograms by knowing my how do you proofs. Again, this sheet right here, you should be referring to throughout this entire unit. I need to use my how do you proofs. And then once I have my how do you proofs, I just need to calculate the distance and put it into the structure of proof. Use these as examples. There's only one example that I skipped. That's what you can do for homework. And I hope everybody practices this and have a great day.